Welcome. Today, we are exploring the technical ecosystem powering modern football. For the 2026 World Cup, the beautiful game has evolved into a deeply integrated cyber-physical system. We will be looking under the hood of the data-driven pitch, from 500 Hz internal ball sensors to 29-point digital twins, to understand the robust IoT architecture that makes it all possible. Football has officially transitioned into a real-time data event. The 2026 World Cup doesn't just happen on grass. It operates on a massive, unified IoT infrastructure. We can break this ecosystem down into three core nodes: the ball, housing a 500 Hz IMU chip, the player, mapped by 29-point skeletal tracking, and the stadium itself, running on a sophisticated 4-layer IoT architecture. Every physical movement is digitized, processed, and acted upon in milliseconds. To understand where we are, we have to look at how quickly officiating technology has evolved. In 2018, VAR relied on standard video and manual line drawing. By 2022, we saw semi-automated offside technology and a suspended sensor inside the ball. But 2026 represents a massive leap forward. We have moved to real-time digital twins, an innovative side-mounted ball sensor, 50 Hz skeletal tracking, and decision outputs driven by fully animated 100% pre-scanned 3D player avatars. Let's start with the focal point of the game, the ball. This is the Adidas Trionda. Engineered with a historic low of just 4 thermally bonded panels, its aerodynamics are highly stabilized. But the true innovation lies inside. Shifting away from the suspended center bladder of 2022, the Trionda features a side-mounted KINEXON inertial measurement unit, or IMU. This specific mounting optimizes weight distribution while delivering uncompromising data accuracy. That KINEXON sensor is capturing acceleration and 3D spatial movement 500 times every single second. To put that into perspective, look at this waveform. When a boot strikes the ball, the system registers a massive physical event, in this case, a peak G-force of 432 grams during a spike that lasts merely 5 milliseconds. The sensor detects this exact delta V threshold, providing an indisputable timestamp for the exact moment the ball was kicked. While the ball reports its own metrics, the players are being constantly digitized. 12 dedicated high-speed stadium cameras track 29 distinct anatomical points on every single player, 50 times per second. This extremity tracking is computationally heavy, but it is absolutely vital. As you can see here, the precise location of an extended toe is frequently the deciding factor in modern offside mathematics. What broadcasters and referees see are no longer generic flat graphics. They are highly precise digital twins created through a 2-stage pipeline. Pre-tournament, all 1,248 players step into a 3D volumetric scanner to capture their exact body proportions, generating a static base mesh. During the live match, the 50 Hz optical stadium cameras capture the dynamic motion skeleton. Merging these two inputs yields a real-time, mathematically accurate animated broadcast avatar. Neither the ball nor the cameras can make a ruling in isolation. The intelligence of the system relies on sensor fusion. We take input A, the precise timestamp from the 500 Hz IMU in the ball, and instantly marry it with input B, the exact spatial position of all 29 limbs captured by the 50 Hz optical cameras. The AI processes this fused data to generate automated alerts, sending them to the VAR room within seconds. Let's look at this in action during the Croatia vs Portugal round of 32 match. To the naked eye, and on the standard broadcast feed, the 103rd minute equalizer looked like a clean pass. But the data view tells a different story. The IMU waveform detected a microtouch by Igor Matanovic at exactly 103 minutes and 42 milliseconds. At that precise millisecond, sensor fusion confirmed Mario Pasalic was 0.014 meters over the offside line. The goal was rightfully disallowed. The technology extends beyond officiating into player safety and performance management. To combat extreme North American summer heat, players are utilizing the ClimaCool system, motorsport-inspired thermal management. This includes pre-match frozen gel vests and insulating jackets to significantly lower core and skin temperatures, as well as post-match cooling overshoes designed to drop foot temperatures by 2 degrees in exactly 7 minutes to accelerate recovery. Zooming out to the macro level, managing millions of fans and high-value assets requires a structured digital foundation. The Smart Stadium is built on a robust 4-layer IoT architecture. It begins at layer 1 with identification, like RFID HIA cards and BLE tags. Layer 2 handles sensing, such as time-of-flight parking sensors. Layer 3 provides the connectivity backbone via BLE, LoRaWAN, and 5G, which all feed into Layer 4, the application layer, driving crowdflow dashboards and asset visibility platforms. This architecture creates an invisible supply chain that operates in real time. By dynamically tracking fan movement through RAIN RFID gates, monitoring the location of critical medical kits and broadcast cameras via BLE trackers, and guiding vehicles to open spaces with TOF parking sensors, operators completely eliminate operational blind spots. This prevents physical bottlenecks and ensures life-critical equipment is never lost. To power an ecosystem this dense without systemic failure, operators rely heavily on 5G standalone and edge computing. The critical strategy here is network slicing. By logically partitioning the network, we ensure that life-critical and match-critical data, like the ultra-low latency VAR data, are completely isolated. A stadium full of fans uploading videos to social media on the best effort slice will never compromise the sub-1 millisecond latency required by the officiating slice. Ultimately, the value of this massive IoT deployment is not just in gathering data, but in the operational loop it creates. It is a continuous cycle: detect via sensors and gates, transmit securely over 5G slices, analyze through central dashboards and AI, and finally, respond, whether that means sending an automated VAR decision to the referee or physically redirecting crowd flow on the concourse. This is the invisible game. The 2026 World Cup proves that modern sporting events are no longer just athletic competitions. They are some of the most complex cyber-physical systems on the planet. Through advanced architecture and high-frequency IoT, the gap between what happens physically on the pitch and what can be mathematically verified has quite literally been narrowed to milliseconds and millimeters. Thank you.